Hey guys, today we're going to start talking about solving equations with variables on both sides. To start it off, I have this mini little problem thing. You are the new ruler of Equation Kingdom. Congratulations. In your kingdom, there are many problems that arise. In order to solve these problems, you decree that all of your variables shall live in variable land, and all of your constants live in constant land. You're really just, segregating your citizens. What a ruler you are. How does this help solve your problem and create many others? So you'll see that for the first two, they're the same exact problem. We're going to solve them in two different ways, really solving it the same way though. So we want to get our constants on one side and our variables on the other side. So if I look at this first one, I'm going to split these two down in half. I can say that the left side is going to be variable land and the constant is going to be in constant land. Well, in variable land, I can't have that 7 hanging out there because it doesn't have a variable attached to it. So I'm going to get rid of the 7 by using its inverse operation and subtract 7 on both sides. Well, now that I look at constant land, I have that 4x over there. That's not a constant and has a variable term attached to it. So I'll subtract 4x using its inverse operation on both sides. So when I subtract 7, I'm just canceling out this plus 7 here. And then when I'm subtracting the 4x, I'm just canceling out that 4x there. So then on my left side, I have negative 8x minus 4x, or negative 12x. And then on the right side, I have negative 5 minus 7, or negative 12. Now all my variables are on one side, all my constants are on the other. Now I can go ahead and solve this equation. I have negative 12x is equal to negative 12. To get x by itself, I can go ahead and just divide both sides by negative 12. Canceling those burrs out. I have x is equal to negative 12 divided by negative 12, which is 1. So I solved it being x equals 1. Now there is technically another way to solve this. I went ahead and said that variable land is going to be on the left side. Well, this time I decided it needs to be on the right side. And constant land can go ahead and live on the other side. So I can't have that negative 8x hanging out in constant land. We need to get rid of them. I'm going to go ahead and add an 8x to both sides. Just like negative 8x, I can't have that negative 5 chilling out on the variable side. It doesn't have a variable with it. I can just add 5 to both sides using inverse operations that will cancel that one out. Just cancel that side out. So after making sure all my variables and constants are on the same side, in constant land, I'm left with 7 plus 5, or 12. And then in variable land, I'm left with 4x plus 8x, or 12x. Just like in the last problem, now I have a one-step equation. I know how to solve this. Using inverse operations, I'll divide both sides by 12. Canceling those burrs out, I'm left with x is equal to 12 divided by 12, or 1. Just like the other one I got, x is equal to 1. Now, what if I really don't believe it? What if I don't think, I'm telling the truth, I'm getting the right answer? I could just check, right? I can take 1 and substitute it into the original equation. So I know that x is equal to 1. I need to put it in for x here, and I need to put it in for x there. So I have negative 8 times 1 plus 7 is equal to 4 times 1 minus 5. Then I have to make sure that both sides are balanced. So I have negative 8 times 1, which is negative 8. Bring down that plus 7. Then negative 8 plus 7 is equal to negative 1. And then looking on my right side, I have 4 times 1, which is 4, minus 5 is equal to negative 1. Negative 1 is equal to negative 1. That means I have my correct answer. This kind of looks like a heart here, because I love math so much. Hooray. Do I have to do it both times? No, just pick one. What I usually do is whichever side will get me like a positive number to divide by, positive coefficient. I usually go that side. You could also just always bring your variables to the left side. It'll always say like x is equal to. Doesn't really matter, whatever you want to do. So we can work through these together. I have 7x plus 19 is equal to negative 2x plus 55. So I'm going to go ahead and try to bring my variables over to my left side. So I have minus 2x there. I'm going to add 2x to both sides. That cancels this 2x out. And then I'm left with 7x plus 2x, or 9x. I do have a two-step equation here. I can subtract my constant from both sides. By subtracting 19, that gets rid of that plus 19, leaving me with just 9x. 55 minus 19. Sorry, I had like hair on my screen. It's equal to 36. Still not done. I have to get the x by itself. Because I'm multiplying it by 9, my inverse operation would be to divide by 9. X is equal to 4. However, I don't know if that's the correct answer. I do need to make sure that I check. I can do that over here. My check. Taking this 4 and substituting it in for x on both sides. So instead of 7x, I'll have 7 times 4 plus 19. And instead of negative 2x, I'll have negative 2 times 4 plus 55. 7 times 4 is 28. Plus 19. 7 carry the 1, 47. Quick maths. On the other side, the right side, I have negative 2 times 4, which is negative 8, plus 55. Quick maths again. Yeah, it's 47. She checks out. That means x equals 4 is my correct answer. Hooray. Excuse me. Yeah, try this one out on your own. So pause the video, give it the old middle school try, and then when you're done, unpause it, and I'll go over how to do it with you. Did you pause? I hope you paused. You didn't pause, and I'm just going to sound silly right now. If you did pause and you're listening to this, I'm sorry. I just need to ensure that you're all pausing. Draw that line down the middle. I'm going to go ahead and try to get it onto the left side. I think that sounds fun. So I need to get rid of this negative 3x. I can do that by just adding 3x to both sides. That cancels them out. So I have 6x plus 3x, or 9x. I have 9x plus 22 is equal to 31. I need to get rid of that constant, move it over to constant land. I'm going to subtract 22 from both sides. Cancels that out. I'm left with 9x is equal to 9. To get x by itself, I can just divide both sides by 9, giving me x equals 1. I thought that was my answer for the last one too. It's the one up here. I don't know if that's the correct answer though. What if I messed up somewhere? I should probably check to make sure. In my check, I'll have 6 times 1 plus 22 is equal to negative 3 times 1 plus 31. On the left side, I have 6 times 1, which is 6, plus 22 is 28. On the right side, I have negative 3 times 1, which is negative 3. And then negative 3 plus 31, which is 28. Smiles. Good answers all around. And look, I'll throw in a star too. Boom. Down here, this problem looks a little bit different. I have 80 minus 9y is equal to 6y. There is no constant over here. Well, technically there is. You could say that there's a plus 0 here, but we're not going to include that because mathematicians were lazy. Why would I bother putting that in there? So when I split in half, you could subtract the 6y, and then it would be equal to 0. Or I could just move my variable over to the other side. Those two cancel out. I'm left with 80 is equal to 15y. Divide both sides by 15. Ooh, that's not an even answer. So I have y is equal to, I could take a 5 out from the top and bottom. 1, 6. Take the 5 from the bottom, that'd be 3. 16/3 is my final answer. Let's check though. How do I know that's the correct answer? I'd have 80 minus 9 times 16/3 should equal to 6 times 16/3. So first I have to do 9 times 16/3. So 3 and 1, 3 times 16, 48. And then 80 minus 48, I got 232. And then on this side, I just have to do 6 times 16/3. So that turns to a 1, I get a 2, and yeah, that equals 32. Hooray, the correct answer, 16/3. What a beautiful answer, I love it. This one gets 2 stars, but no check marks. Go ahead, pause the video, try out this next one. 64 minus 12w is equal to 6w. Just pause it and try it out. Did you not pause it? You know, I know when you don't pause it. I get a feeling. And then I'm like, why wouldn't they want to try it? Alright, I'm just going to have to assume you paused it. Here I go, pretending that I know that you paused it. Hey, thanks for pausing it. Let's see if you got the same answer as me. I'm going to go ahead and move that 12w to the other side. I'll do that by adding 12w. Now cancel these two out. I'm just left with 64 on the right side, on the left side. I know my lefts and rights. 6w plus 12w is 18w. Excuse me. Divide both sides by 18. Cancel these out. 18 can't go into 64 again. I can take out a 2. Yeah, 32 over 9. My final answer. Officer. Yep, that's it. Checkity checks. I'd have 64 minus 12 times 32 over 9. And that should equal to 6 times 32 over 9. Oh, these answers are going to be gross. So I have 64 minus, because that's going to turn to 3 and 4. Ugh. You know what? We're plugging it into a calculator. I'm not dealing with this. We're out of chapter 1. We can check calculators now. Do I have a calculator thing open? No. Where's she at? Yeah, this will work. I was sitting on my OneDrive. Okay. So 64 minus 12 times 32 over 9. 21.3 repeating. I got that answer in my head. And then the other side, I just have 6 times 32 over 9, which is also 21.3 repeating. Oh my gosh. And look, no calculator needed. Hooray! Hopefully you got the same answer as I. It's going to be really funny when you guys are like, I did it by hand because I wasn't sure if I was allowed to use a calculator or not. That's how you guys sound to me. Alright. Describe the error. Go ahead, you can do the error analysis on your own. I'm going to move down to these fellas. Pause the video, and I want you guys to try to solve these. Let's just see if you can get an answer. Go ahead and try and solve them. Assuming that you paused. For this first one, I would distribute the 3 and get 3x plus 6 is equal to 3x plus 6. So already I'm seeing like huge red flags. That's a flag. because we have the same thing on both sides. I have 3x plus 6 and 3x plus 6. When I subtract 3x, it cancels out here, and it cancels out here. I'm left with 6 is equal to 6, which is a true statement. Last time I checked, 6 does still equal 6. So we wouldn't say our answer is 6. We would actually say our answer is infinitely many solutions. I'm left with infinitely many solutions. So I can substitute any number I want, excuse me, any number I want in for x there, and I would get a correct answer. There's no value for x. Yeah, there's no value for x in there. That wouldn't work. For this one, when I subtract x from both sides to get them on the same side, they cancel each other out. I'm left with 2 is equal to 4. 2 does not equal 4, though. That's not a true statement. 2 and 4 are very different numbers. So in this one, my answer is no solution. There's no value for x that I can get that both sides would be equal. Talking about number one problems that people get wrong on the test are these guys. They require like the least amount of work, and really you can catch them like pretty early on, but then people forget what the answer needs to be. So make sure that you're remembering infinitely many solutions and no solutions. And you can do these on the bottom on your own then. Okay, if you have any questions, please let me know. All right.